spiders predate the dinosaurs, scurrying along 315 million years ago, but their precise origins remain a mystery. Now scientists believe they have filled a gap in the evolutionary story of arachnids, with the discovery of a fossil that's the closest relative to spiders ever discovered. The creature, dubbed Idmonarachne brasieri, measured less than 1 inch long and lived alongside the oldest known ancestors of modern spiders 305 million years ago. It is hoped the specimen will help scientists understand more about the early origins of modern-day spiders. The fossil was collected years ago in Monsoles mines, eastern France, but has only just revealed its creepy secret, since the first part of its body was encased in rock. Now, researchers from the University of Manchester, Berlin's Museum for Naturkunde, the University of Kansas and Imperial College London have worked with the Natural History Museum and the Diamond Light Source in Oxfordshire to reconstruct the prehistoric arachnid's body using CT scans and high-powered X-rays. They were able to do this because the fossil was preserved in 3D, enabling the researchers to investigate its minute anatomical details. The fossil was rediscovered in a box full of rocks at the University of Kansas, having originally been collected from a rich region of fossil-bearing deposits. Russell Garwood from the University of Manchester, first author of the study which was published in the journal Proceedings of the Royal Society B, told Mail Online, "This animal is the closest thing we have to spiders without being a true spider, so it sits in a key position when looking at the evolution of the group." Not much is known about the origins of spiders, with little knowledge of their predecessors or how they came to get their scariest features. As well as the ancient arachnid's 8 legs, the team spotted it has strong jaws, showing it is a distinct species and not another distant cousin of spiders from the same time, the BBC reported. They also noticed it lacks the tail-like appendage, or flagellum, of an older extinct arachnid family including Atrocopus, which lived 80 million years earlier. These earlier creatures didn't have spinnerets, which allow modern spiders to weave their webs, so a brasieri fills an evolutionary gap because it has spider-like features such as legs and jaws, but no spinnerets. Dr. Garwood explained, "Our brasieri shows us that spider-like ancestors lost a tail, which older, closely related animals called arachnids hadn't developed spider-like limbs and mouthparts, but that the key innovation which defines spiders is their spinnerets. These are small structures on the underside of the animal that help them control silk." He added that brasieri probably split off the spider line after Atrocopus, but before modern spiders appeared. The earliest known spider fossil was found in the same mineral deposit and has spinnerets. So what we're actually looking at is an extinct lineage that split off the spider line sometime before 305 million years ago, and those two have evolved in parallel, he said. Our new fossil occupies a key position in the evolution of spiders. It isn't a true spider, but has given us new information regarding the order in which the bits of the anatomy we associate with spiders appeared as the group evolved. Dr. Garwood said the innovation of spinnerets may be what makes spiders so ubiquitous. There are more than 45,000 known species, compared to a little over 4,500 for mammals, for example, which makes them among the most successful arachnids, he said. This success also makes studying their origins and early evolution, both things about which we have relatively little information, a really rewarding thing to do. The new species is named Idmonarachne brasieri in honor of Professor Martin Brasier of the University of Oxford, who passed away in December 2014.